Managing, say for example, I have a storage controller. You're not actually managing the controller of that. You're actually exposing, you're taking existing data that's already exposed, right?
Correct. So I'll take you through that, I think.
I would just...
Yeah, totally. And I think this is one of the breakpoints where I'm supposed to say, I'm Douglas Fallstrom. We're from Hammerspace, run the product team. And I'm going to switch and finish answering your questions, which actually we didn't answer fully yet. Halfway there, but not quite yet, about how it works across sites. And then David is going to switch to showing you how it all works. So as we designed this, and as we brought this to market, and we fiddled on this for years, we also wanted to go to this multi-world of many sites, and 2 is the picture here. We start with 16. The architecture is thousands. No one's going to do thousands anytime soon, but it's a lot, right? We also decided that each site needs to be able to be available individually. Network problems, partitioning, whatever you might have between sites cannot get in the way of making sure data is served to the user, unless the data obviously isn't local, but just a different discussion for a second. Within each site, you run Hammerspace. Hammerspace is always 2 components. There's the metadata servers, and then there's the data services. Data services are kind of workhorse. They move data. They dedupe. They figure out what the data needs to be moved, and they also provide a proxy in case we need to move data live. We can move data anywhere in the infrastructure without a single disruption to the client. That alone makes us quite unique, because that means that you can kick off a data migration job, a cloud migration job, you can decommission storage, you can add more storage, all non-disruptively in the environment. There's not a single piece of disruption. Not an IO flush. Not an IO flush.
Speaking of disruptions.
Not IO flush, not a client that just pauses for a second. If you look at the IO stream, it just continues. And there's a lot of work that went in by John and the team for not only implementing it, but also driving it through standards on the NFS side. Okay? The other piece we implemented...
The clicker's working now. It's working for you.
Fantastic. The other piece we implemented along the way is the fact that we want to also make data not only optimized as it moves into object, and we use object as a transport between sites for data payloads. We're not dependent on object in any way except moving data between sites. You can have a site have all NAS storage, all block storage, and an object is just an intermediary when you move data across sites. We also implemented compression, global deduplication, and also encryption with customer key management solutions. So we don't have our own. We intentionally did not have our own at this point, because it kind of takes away from the fact that we would own the keys to the data, and that's not the point. The point is that the customer wants to own their own keys to the data, especially when it sits in the cloud. And I'll give you an example here in a minute on the customer doing that. Metadata is replicated point-to-point between metadata services. That allows us, like David mentioned earlier, to scale the metadata replication very aggressively. It's not much information. You can replicate metadata infinitely much faster than gigabytes and petabytes information. You might have 100 petabytes or petabyte information on this site. You might have 100 terabytes in the cloud. You still see all your data like it's there, but it's actually not present until you either access it or it pushes it by policy. And the policies we'll show and talk to. On each site, you can access data concurrently over parallel and NFS, NFS 4.2, NFS version 3, SMB2, SMB3, all the regular dialects, not screw up the applications that you deploy today. You can take an application on-prem and simply run it in the cloud using the same data protocols you have today. Object is also coming here, so soon you'll see an S3 interface into the same namespace. And suddenly it doesn't really matter what you talk with storage, because all those protocols are exposed externally. The other piece that's important to note, we support all the public clouds. We're in the marketplace for Google, for Amazon, soon for Azure. Right? So the goal is to be able to get Hammerspace to be available very easily. We can run on physical hardware and virtual infrastructure. We can run soon containerized. Getting the product up and running is simple and quick.
So, right back to that previous, when I'm doing block storage and I'm doing iSCSI, whether it's iSCSI or fiber channel, where does this inject itself in the data path? At what level? So help paint the picture for me from a physical, here's my data path, and this is where Hammerspace comes into play when it comes to...
I feel like it's a whiteboarding opportunity.
And
messy whiteboard.
to Keith's question, is what you're about to address cover who's handling data locking and integrity of that?
Yeah.
And also, how do you inject yourself in the path without slowing things down?
Yeah.
So-
Sure.
I think
We'll add all of those to that.
my concern basically was that, and I'll just speak about it, is that if you have eventual consistency, especially, for example, you're working on premises, right? And your data is not there. So AWS, say, for example, the other environment is there. You have a global namespace, and partly the reason to have that is so that you can do whatever you want to do with a uniform URI, right? So you can get that resource immediately. But the data isn't there anymore. At that point, it's on demand pretty much, unless by policy. So how do you ensure all that consistency, especially when transactions are very fast?
Sure. And I will pause that question because David's going to show you.
Okay.
How that works.
Yeah, let me
and I'm going to take the first one first. But yes, they're all kind of tied together. So in an environment, where you have block and NAS, just to complete the picture, right? What we do on the top, we speak SMB and NFS, and soon S3, right? So you have the protocols on the front end that goes up to the app. We don't do block on the front end unless we speak to container storage interface, and I'll show you that as well. We're not a vPlex or an IBM SVC. We have no intention of doing that at this point. On top of DSX, to show it, it goes in, so on top of block, it pipes into a DSX data services node. Okay, so we get block in from the bottom, we slap an XFS file system on it, and that's part of a NFS v3 target volume in the global namespace. Okay. So we simply take the block storage, we put a file system on it. You can have as many of those. You can do EBS and Amazon. You can do, you can do 100 volumes for a DSX. You can do 100 DSX with one volume each. It doesn't really matter. There are various reasons why you want to pick one versus the other, or both for that matter. And they simply become targets for where data can live. Data is placed based on SLOs David mentioned earlier. Right. So things
a couple of important things. The DSX is a scale-out service, and it's what goes on top of block storage to allow it to become more of a blob store. It performs the block allocation and mapping function that's needed so it can house logical strings of data as opposed to raw blocks. Then what that speaks is, go figure, NFS v3, because that's a great way to read and write contents of files. Now the namespace isn't down here, but it allows you to store the content blobs and read and write it using the same protocol that NAS is using. In other words, block storage is front-ended by a scalable services layer, DSX, which allows it then to talk at a higher contextual level and read and write the strings that represent the bodies of files.
I've got two questions. One is a yes or no question, so it makes it easy. And the other one's a little harder. Are you using erasure coding? Question one. All right, no erasure coding. Good, that's the other way. Now, how would this be used to tolerate a US East outage, as an example?
So
Not that way.
We're actually going to talk about the data recovery thing a little bit later if we can table that.
Well, it's not data recovery though, because it's data resiliency.
Right.
I mean, ideally.
Yes.
So before I get to that answer, I want to make sure I answered your question.
Yeah, so follow-on question from, I understand how you present block now. Follow-on question
Use
is,
block, not present block.
Right, you don't present.
how do you leverage block? So I'm leveraging my previous investment. And then this is along those lines of adoption. So we're talking hybrid cloud. So I have hybrid operations. I have legacy applications who just simply won't do this. How is that handled from a namespace perspective?
We got to get to the demo stuff.
Yeah,
because
so
we're going to show a lot of
I'm going to pause on that because we're going to show a simulation. We'll show you exactly how we deal with legacy data, how we include existing data in there. But I'm going to move to the demo for that. To answer your outage question a little bit, I mentioned earlier we designed this to be independent of each other. So that means that data can be spread across. Let's say you have a petabyte of data. Let's say you only have 80% of your data happens to sit on this side over here, 20% sits over here. When you lose the site, the metadata still makes all the data presented. Right? You can easily navigate on namespace, showing the data is available locally versus not locally, for example. If you try to access data that is not available for a moment, it would either hang or they will show it in the system earlier. If it actually is available in a snapshot, we're going to recover that automatically. So When the sites come back together again, the systems will just simply stitch together. And that's really a unique aspect of our product. Sites continue to be online, you continue to work with applications, and the systems just stitch together as it becomes online. And we'll talk about this as part of collision detection.
This is actually really important for edge as well, because it means you can operate disconnected. The namespace can evolve and change over time. When it reconnects, it merges, any collisions get recognized, and you keep both versions of them. I'm going to demonstrate that.
We'll pause that for the demo, because I want to talk about two things before we move to a customer example on how to use it. One, we talk about we can support in the back end any type of storage that the customer either already has or might invest in the cloud. We talk about live data mobility. We talk about all these aspects. We'll talk about the global namespace, multi-protocol, universal active-active. I don't think we have any questions on this piece. We work with one of our customers. They do several different things. One, I can't share their name because they're in the legal services. They're one of the bigger law firms in this country. We're not allowed to talk about their name, but this is what they're doing today. They have many offices across the US. They have three, their main offices. They have their data centers or mini data centers in them. The challenge, often they have cases that they work across the US, and you just don't sit in a city. They're big firms they represent. So the challenge to get access to the information locally, all their lawyers and legal services teams, they all work on Windows, all have SMB access. Anybody that's tried to mount SMB over the internet knows already it doesn't work at all. It's extremely painful. So they're all in our environment. We solve that problem completely, but also we want to make sure that we can meet their tier 1 capacity asks, right? So they have data centers across, it's expensive. They don't want to have all their data, even for cases that are 10, 15 years old, sitting on tier 1 storage. But they need it accessible and safe.
So then your primary use case would be customers who need to replace their file shares. So this wouldn't be to host, say, a database.
This is except Kubernetes, but yes. Unstructured data focused.
Okay.
And I'll talk about Kubernetes later in the presentation, so I'm going to table that piece. But we have some aspects to make database in Kubernetes is extremely powerful with us. The two things we solve for them. One, we automate the workflow. We talk about metadata, and Dave's going to show you can add tags, you can add information to the data that helps us determine what data needs to be everywhere. You don't want to put all your data on every site because it doesn't scale if you have a lot of data, and you probably don't need to. Two, we encrypted with their hardware on-site KMS, which allows data to move into the cloud without the single risk of anybody in the cloud being able to get to the data and understanding it. Their on-site hardware KMS is extremely well protected, as you can imagine. So even if they misconfigure the cloud and give people access to data blobs in the cloud, they can never read the data. Right? So it makes it very secure. And the key here is integrate with a customer-managed system, not managing ourselves, because it's just another single point of failure for us if we're doing it. Two, we optimize the traffic. We talk about global dedupe and compression. A lot of these is text-based information, ignoring the movies and pictures and everything else. It's compressed extremely well. So data moves very fast across sites. And also, we've added an Undelete, and David's going to show you this. I think we're the world first with a, and I hate to call it a trash can, but it's an Undelete for NAS and shared data. You can put policies on this, and I'm going to pause there because I want David to get a chance to go through that in specifics. So go right ahead.
Okay, first, that diagram that you saw of two sites, a couple of back here, this, I have running actually on my laptop. I'm running a data service node, a metadata service node representing data center 1, and another pair. Those are actually all running as VMs on my poor little 4-core laptop. So I'm simulating two entire data centers. Here's the one Anvil and DSX, and here's the other. I've also got a Linux VM so that I can do things from there. This is the console. On site 1, I have a file share called test share, and on site 2, I have a file share called test share 2. Now, those are actually replicas of each other, connected by like a wormhole where the metadata is leading it, and the data only follows if and when needed by policy or on demand. Now, I'm going to go to my Mac where I have test share mounted and test share 2 mounted. Note, these are mounted over NFS v3. I could just as well mount it over SMB. Because these are old protocols that have metadata and data combined, it goes through the data services layer which is a scale-out stateless service, but it resynthesizes metadata and data together to serve the older protocols. In the Linux world, going to your question, native Linux clients that are now upstream know how to talk parallel without the intermediary layer. Now, scale-out NAS systems like Isilon have an intermediary layer to route it across the back end. That's why they internally used InfiniBand, right? Once we move that routing function into the client with a directory services look-aside model, then it becomes parallel. So not only do we not sit in the data path making yet another bump in the wire, but we actually eliminate the need for it to be a two-tier architecture like scale-out NAS has been in the past.
So you're a storage driver.
So we have elevated the data services out of the storage array, including what it takes to distribute the data with parallel access. So we're not storage, we're a services layer, but it does the routing and it takes many of the services that you are used to consuming from the infrastructure and pulls it out, not the least of which is the file system itself, okay? And making it into a true parallel file system. By the way, these concepts of separating the metadata from the data and having a parallel data path, before I created Fusion.io, I was chief architect at one of the leading HPC companies, and we built some of the world's largest supercomputers. And in the HPC space, the model that you use is separate metadata from data, but all of that is to get sheer performance. What we've done here is said, let's use open standards, and let's use it to solve the data management problem, and just get for free the performance stuff as well.
Yeah, but in those HPC models, that was all with gear that was like right next to each other, and you could use technology.
Well, and that's the thing. Going to the question about the domains, within each data center, this is served as a parallel file system, strictly coherent with all of the locking and all the expectations. It's only when you go between data centers that you have the eventual consistency. So I'm not trying to solve how you write to the same file at the same time, et cetera. I'm talking about how do I work in the same namespace with different apps working in different sections or different pieces of data being consumed in different ways. So I'm not trying to solve the speed of light, because you can't. And trying to put locking across them will kill you.
So you are not a storage company. You are a data provider.
I'm a data services company.
You're a data services company. And so you've got a slide back or so, you've got, we can do snapshots and give you an undelete option for NAS.
Those are data services.
Those are data services.
That's right.
Where is that data being stored for that snapshot instance of it?
That's all in the metadata. And it's just how the metadata is mapping the older
data
versions.
in the metadata.
So those are just, yes, exactly. The metadata, no, not the data. The metadata is got the name of the file, what the version it's at. It's indexing everything. It's the index. It's the card catalog. It's referencing the data blobs that sit on storage, including those that represent the snapshots.
In context, I go and I delete 1 billion files off my NAS. It happens, sometimes unintentionally. Oops, I've got this function in here. I'm going to go restore those 1 billion files. But where are they? If they were purged off the original repository, I've got the metadata, but then where does the data sit?
So if you're using Hammerspace, then you have the snapshots and your accesses through Hammerspace, not directly to the back end. If you go to the back end, you're just going to see blobs.
Yeah, no, I get that.
So,
but that's what I'm saying.
But if somebody were to accidentally destroy a bunch of those blobs, then if it's in a snapshot or if it's been orchestrated by policy onto other storage, we automatically recover it.
Well, if
the data's been
orchestrated by policy to other storage, I already have a resolution in some other fashion or manner. Okay. I'm just trying to address, it was raised, we can do snapshots in there. I want to know how can I restore that?
So while David preparing for the demo, so let me explain.
Yeah.
Because
I've seen that happen so many times. For
snapshot specifically, the way it works is that we take a snapshot of the metadata layer, just like David explained. At the data layer, the data remains in place unless you have a policy to move it somewhere else. Because we're managing the pointers to the metadata, you're not deleting the blobs, you're deleting entries in the metadata. So if you're doing, let's say, an rm-rf on 1 billion files from Linux, whatever, all those are metadata updates for us. If they have, let's say, an undelete objective on it to keep it for a week, that's handled for us, and the blobs on disk are never even touched.
So I can't use this as a benefit for like ransomware type.
You absolutely can, and that is one of the ways the law firm is using it. Okay, but yeah, let me get there.
So there can be a policy set that, like, if data is deleted, it's not actually deleted.
It's not actually deleted. That's our undelete policy that we're talking about. Okay, so look, I can drop some files into share 1, and I can take and drop. That's 1 through 10. I'll drop some others through the second share. So I've dropped some in share 1, I've dropped some in share 2. Now, as I look at share 1, I see 1 through 10. Share 2, I see 11 through 20. If we wait just a second, those become consistent and they show up. Actually, it's much faster than what you're seeing here because the Mac doesn't update the preview that quickly. Now, on share 2, I'm seeing the files that I dropped in from share 1, and the time that it takes, it's actually transferring it to the cloud and back, because I am still using a real bucket in S3 as the transfer mechanism. By the way, the reason we use the object store is because the data that's there is single instanced, compressed, deduped, encrypted, and so you're only ever sending the new and unique strings of data. In other words, it represents a catalog of known strings, and you don't have to transfer anything but once between any two sites. In other words, it's inherently a WAN optimizer when it comes to the exchange of data. So as I look at these things, this is site 2. He now sees the first set of stuff that was dropped into site 1, and site 1 now sees the stuff from site 2. But because I'm only now previewing it, it's actually having to transfer these files just to service the preview request. If I look at our console, I can see the mobility that has occurred, the transfer of data between the two sites. Nothing's ever as fast as you want when you're showing a demo.
While you're showing that, I'm curious about whether you're predictive about what the next file or set of files might be for someone who's accessing a share. So to help with the replication.
So that's an interesting area for enhancement. Right now we put the focus on the policy so that you can actually have it pre-stage and have on-demand be fast. But there's something in between those, which is to have the demand imply and automatically infer other sets of files. Haven't done that yet, right? So the two extremes we've done, policy-based and strict on-demand, but the predictive on-demand is kind of at the edge of what we have.
Your policy-based is basically saying, I want this set of files always available on these targets.
That's right. And it might be to protect it, or it might be to pre-stage it so you can use it. And you can put that policy on the snapshots too. You can say, when I make a snapshot, my most recent snapshot I want here. As it ages, I want it to go there. And the data will get orchestrated to meet that policy. And because the snapshot is still connected to the live file system, if the files haven't changed, it will automatically recover it from one of those other storage places if you have an outage of some of the underlying infrastructure. In other words, it all becomes redundant for each other because it's all centrally cataloged.
And what about policy for security, like for exfiltration or access by an application that it shouldn't be accessed by?
So those are, my chart's gone. The access control layer. So this has the very sophisticated ACLs that you would expect, where you can do groups and users and all of those things that you can do both in Windows and in the modern storage networking standards. So that all exists. Those are gating the front door, who has access to what. And now, because we're replicating this, we're assuming that it has the same Active Directory user domain at the different sites. So we're not currently replicating to places that are sitting on a different AD domain. That could be translated, but then it's just based on the principal name having to map, and that's a little risky.
Name or is it going GUID?
It's shipping it around as principal name and remapping it at each site. So technically, you could use a different AD domain as long as it can translate the principals.
Now, one question is, in the example of the demo part you're going through, we're using like 20K files, which is cool because that works, especially given time.
Yep.
But do I have a ceiling? Because oftentimes we're talking NFS file systems, I'll have objects out there. In the legal firm example, you're going to have files that are, that are tens of megs or gigs in some cases, especially if it's, case law. But I've dealt in gigs and terabytes of files.
So we don't make any further constraints on the size other than what you might have for the NetApp or the Isilon that you're using that have some constraints. So let me show the policy stuff quickly here. I can just put a policy that says, keep me a copy on the cloud and keep a copy on this local data service node. Just by that, now everything that's in this share is deemed to be out of alignment with the stated policy. So these yellow dots are because it hasn't yet made the second copy. But even in just what we've been talking, it has now uploaded these to the cloud, And if we look at the mobility chord diagram, you can see the flow of data. Well, we can see that it's created, all of these things are now up in the cloud and on-prem. So if I were to lose that NetApp on-prem, it'll automatically reconstitute it, pulling it down from the cloud as needed and put it on another piece of infrastructure.
Okay. Can we briefly touch on something you said earlier? If I delete a file,
it gets removed from the metadata, and whether the data is no longer referenced by that or any other thing in the namespace, like a snapshot, then it might eventually remove the actual body of the file. That way, you're not actually waiting like on an isilon. It's like dog slow, right? This is very fast because these things are all happening in metadata.
Right, I get it. The metadata is deleted, but the actual file is still sitting on the file store somewhere.
If it's no longer referenced, then it is ultimately freed up, and in a timely fashion, like right away. But the system knows whether it's being referenced in a snapshot or not.
Well, you used the term that, because I don't think you talked about the back end yet. So if I'm writing data via your interface, whatever file system that's being, whatever transport being presented to me, how is it written on the back end? Because you used the term blob. And I'm thinking file, but how is it written to the storage?
So
you're where I'm at.
So
because when you said blob, it actually.
When I say blob, I mean conceptually. It actually is a file on that underlying NFS v3 speaking.
So
device.
if I'm writing whatever the NFS is behind, so let's say it's NFS in front of NFS. So I have the global file system. I have the local file system.
Parallel NFS, front-ending a bunch of standard NFS.
Right, and then
using the standard NFS as the distributed store.
And there's reconciliation if I access the backend NFS directly, delete the file. You guys will eventually catch up and say that file is no longer.
You don't go to the back end and delete.
Oh no!
If you do, the system realizes it and recovers it.
This again is an adoption thing, because there are people that won't use.
Let me show you there, okay? So this goes to what we call a sidecar model, where let's suppose you go into an organization and say, I don't trust you to serve my data yet, but I'd like to get some of the benefit, maybe for a ransomware bunker to create a DR copy in the cloud. So first, if we look at the infrastructure side of things, here's how you add more book shelving to the available bookshelves in the library. You can come in here and simply say, add a storage system. It can be isilon, different EMC storage, NetApp storage, basically anything that speaks NFS. These are special because we tie into their ability to make offloaded copies, so that when a snapshot or a clone happens at our level, we can quickly replicate that string of data and allow it to start mutating in the context of being something different. So this goes back to
what I was talking about earlier, where you actually can tap into specific
data services underneath to accelerate.
Right.
But many of them we don't need. Like, we don't need them to do snapshots. Right. We just need them to do cloning, because a snapshot is completely in the metadata. It's only when they go to update something.
Can I add one thing, and I'll do it real quick, because it actually piggybacks off what Keith just said, because that was one thing I was getting at, or that it clicked about the blobs. If I actually go to the backend storage, I'm not going to see that file name.
You're not. You're going to see a bunch of IDs.
Right. It's going to be a bunch of randomly generated files that are spread across whatever my backend storage is, correct?
That's right.
Okay.
So what happens if one day decide I don't want Hammerspace anymore?
So it's simple. Just, you can pivot it out. There's a button that says export it. It's no different. So just like you have an option with any storage, it's just we're even more agile, both coming in and going than being the infrastructure.
It might be worth adding that we also added an uninstall method that will, rather than exporting all the data and force it to copy everything through the front door, will allow it to consolidate, let's say, share on let's say a NetApp as an example, and just uninstall it, which will just literally rename everything into a structure that would make sense.
Yeah, because that's what I'm really afraid of. It's like, I got to get back to my things that were obfuscated.
But you guys are exactly right that when you step up a layer of abstraction, it makes people nervous. It's absolutely necessary given the complexity of the environment, but you have to make the on-ramp easy. And that's what I'm going to show you here. By the way, one last thing. All of these different types of object stores, both on-prem and in the cloud, the catch-all here is generic S3, but we support many of the native protocols. So this is where you see file and object. Block, as we talked about earlier, is incorporated by exposing it to the data services DSX layer, and I happen to have a block device available to that VM that has data already on it. So as I come in here and say I want to add this block storage, the system automatically detects you have data in here. And this is where the on-ramp becomes easy. I can say, I don't want to touch the original. Leave it in place. What I want to do is replicate it into Hammerspace and make it look like an instant writable clone and have the original stay there. Okay? So now I'm saying I'm assimilating it.
Can you pass that into a, let's say, the ransomware use case example?
Well, exactly. So you can drop this into, like the law firm has, put it next to their NAS environment, simply point it to the different shares. It replicates those and, based on policy, tucks it away, compressed, encrypted, deduped into the cloud sitting in S3 in a way where they can immediately start serving it through Hammerspace if they needed to recovery. So your recovery point objective is basically 0. It's there and ready to roll.
So let's talk about ransomware and compliance kind of bundled together. Okay. On the one hand, hey, we get someone opened up a thing, it started going on encrypting. Do I have an audit trail and report on that? And the second side of compliance is I need to know who's accessed this file over the last period of time. Do we have the the ability to actually introspect and gain that information for fill in blank of ITAR, NIST, any other random type of rules you have to follow and you have to report on things?
The system actually has a very granular set of telemetry. One of the enhancements that we put into the protocol is to track all of the actual accesses, not down to the addresses, but to specific files, what files are being used by which clients and onto what storage.
Is it possible to show us that? Because you opened up those attachments, those sample files you copied. Is there a way to actually see that, what that actually looks like?
So,
if not, it's okay.
Yeah, not something I'm queued up to do right now, but it's part of the metadata, so maybe we'll get to see it here in a little bit. But so what I've done here is I've pointed to this other block storage volume, and merely by setting up the reference to it, it's now connecting through, and it doesn't even have to wait to scan all of the metadata. We set up a referential link, and as soon as that's established, you can start accessing the data through Hammerspace, and it will fetch the metadata granularly on demand. So I could have a billion file environment, and with simply saying, hey, that thing there I want reflected into Hammerspace, it will immediately appear as though all billion files the metadata has been transferred and that you have accessible. Because as you navigate the directory tree, it fetches those things just like a client would and pulls them into Hammerspace. So you get then the ability to immediately assimilate petabyte scale environments and have them reflected instantly into Hammerspace. And once they're there, because it's part of the global namespace, that thing that I imported from site 2 is now visible across both sites. And I could reference different data sources here, and I could reference data sources there, and I've pulled them together under one virtual envelope. So instead of having to create yet another data lake to try to solve it, you basically can do it by reference and incorporate it into the same namespace. So, and then the policy can dictate that, oh, I want this placed into object storage in the cloud.
Yeah. I mean, it's great to have this kind of capability, obviously, when as an application programmer, you can build in references that are standard, and regardless of wherever you then move that application, you'll have that data available. So I'm thinking now that, like Nate was saying earlier, that if you, for example, for whatever reason, you decide that you're going to part ways with Hammerspace, I'm not so much concerned about having a share and having all that data exported back to the share. You can create a namespace and do that. But what do you do with the applications? Because you've put those references.
Well, again, you will have to point those applications to the specific infrastructure that you exported to. And now you're bound to that infrastructure.
But typically it won't be global, for example. Say, for example,
So, in other words, if you become addicted to the features that we offer, then yes, it would be difficult to go back. That is a fortunate problem that we hope to have. No, absolutely.
Hotel California.
There you go.
There's no overcoming it. We want to do something that's extremely valuable, that's differentiated from anybody else. If you get to where you use it, then guess what? You're not going to get it somewhere else. But I'm not charging you like a storage vendor would, because I'm not charging by capacity, right? So, or as a storage thing, this is a services layer. So now, what happened, by the way, because I put the policy on site 1 that said I want to copy local and in the cloud, when I referenced something and imported it into that namespace from site 2, it has the policy, and now site 1 basically pulled everything over and laid it out how it wanted. In other words, each site manages his own house. All of the book shelving there, it's like an independently run library. The fact that the metadata is replicated means that it gets visibility to those things, and then it applies its policy and so forth to drive it, which is why it can operate independent. If that first site goes down, so I could go and reference a whole bunch of stuff, replicate it to the cloud, and then I could shut this site down. So the cool thing is that the file system, the namespace, is not only transcendent of the underlying storage, it's also transcendent of the Hammerspace services engines that are running it at a given site. And when you share that namespace to another site, the first site can be shut off, or you can share it amounts and they can be turned on and off and participate in rendering and managing that data environment. But the data environment is actually something that has its own PKI provable identity and is something that's shared and exists outside of even the Hammerspace things.
So
that makes
you
sense.
just said licensing, well, I'm using the word licensing. You're saying you're not charging by capacity, but you're licensed by capacity.
So
right?
we're charging based on the amount of data under management, but not as if we were a storage vendor with all of that. This is more like a data services would charge, not somebody who's marking up.
You're charging
I'm not
based
marking
on the
up disk
projected
drives.
storage, not the size of the metadata table.
Yeah.
That's a tricky one because
It
when
is.
you get into the world of backups and they're charging for how much data you have backed up, it
that's a
becomes a
similar
question of, are you charging me for how much I've ingested and I'm backing up, or for how many copies of that data,
what's interesting
or
is
how many locations?
we're charging by the amount of data under management, which when it's put into object storage can be very compact because it's deduped and compressed. And so our own efficiency could work against us, but it works on behalf of our customers to where if they're using us to tuck a bunch of data into the cloud, not only are they not having to pay Amazon for the duplicate and compressible data that they're putting up there, but they don't pay us either because it's compressed.
Is it a subscription base like everything is going to?
Yeah.
Okay.
Of course it is.
Of course.
I have a requirement to have my files encrypted. How does encryption play into this?
Okay, so twofold. In the object store, we do the encryption, the dedupe and compression. If the object store supports erasure coding, then great, but that's up to the storage that, the bookshelves that you add. Those are characteristics of those bookshelves. But the encryption and the dedupe and compression, we do all of that when it's being put into object store, because that's presumed to be a capacity tier. When it comes to your block and file bookshelving, those are direct and native. Now, if under the covers they support encryption, that can be part of the metadata and go into the policy that says this type of data needs to be stored at rest on things that are encrypted, or even in flight needs to be encrypted, in which case the system would select only those cabinets that comply with those requirements. But we're not the one adding the encryption in that case, if that makes sense.
Yeah. So once on object storage, does the object store, say for example, if they have data lifecycle policies, do they also get used? For example, I don't know, data going into long-term storage, archiving.
So in a world where you're moving the data management to this declarative policy model in Hammerspace, it becomes beneficial to treat the bookshelves more as pure plays and have them export what they're good at. In other words, if it's a hybrid thing that has both flash and disk, it would be better to carve it up as a all flash volume and all disk volume and export both of those to Hammerspace to have it be the thing to distribute the data, because we can do it based on policy and granular from the outside. And then whether it's going between flash here and disk there or doesn't matter.
I do want to steer it back to the encryption for a second, because we talked about encryption of the data, but what about encryption of metadata? Because sometimes sensitive or valuable information can sit in the metadata about a file.
It'd be possible to have our Anvil sit on top of encrypted storage. This, of course, he has to operate. So this is a highly protected zone, very secured as a software appliance that's deployed virtual or physical, that's been through many of the screenings to make sure it's sealed off firewalled and intrusion protected. But that's the kind of stuff we do with some of our larger customers who are, of course, very sensitive. The good news is this is based, Anvil and DSX are based, go figure, on Linux under the covers and a very industrial grade one.
What database system is Anvil using to manage the metadata?
So the metadata is actually using a high-performance Flash native object store that, a little history here, I sold Facebook over $1 billion of Flash. And it was before they were even as large as Facebook. It allowed them to scale their service. As a matter of fact, I cannibalized my own business because the Flash was so powerful they could run from 2 data centers and didn't need to put in a third that they had planned. But that Flash was mainly in support of their systems of record, not a cache, but their actual user database that holds everything. It's a distributed database. And that is in RocksDB.
Okay.
So we help them tune that all out for very high performance Flash. And it's a log structured, it can do checkpoints. If we wanted to go into how we protect the metadata, we synchronously replicate it. As you've seen, we asynchronously replicate it. We also checkpoint it and write those checkpoints to storage volumes. So it ends up being protected 3 and 4 times over, depending on how you look at it, because that metadata becomes the keys to the kingdom. Now, it's much easier to protect that smaller amount of metadata. And the data is very resilient because you can have multiple copies and the system automatically goes and finds, goes and uses additional copies where needed.
Sure.
Okay, so let me show a couple of things here. Now, because the policy was set, when I imported by reference the other data, it got copied over to the other site and put there. Now, if I come in here and set a policy, for example, say, set it to undelete. Let's say I'm going to make daily snapshots. So I'm going to set my undelete to retain deleted data for a day. So now if a file gets created and deleted before a snapshot gets made, it'll still show up in the snapshot because it's retained under the covers, including the directory structure that it goes in. So as you then, if I were to come and throw away some of these files, now that I have that policy on there, then I go look at the undelete. They're here with a suffix that describes when exactly it got deleted. Because you might create and delete the same file over and over again. Each of those versions will show up in the undelete world. Now, this stuff will disappear after a day, but if you make a snapshot within that day, it gets captured within the snapshot and you retain it. So there's a kind of a tension because people use snapshots to try to rescue users that accidentally delete stuff. But if those snapshots are not fine-grained enough, then they don't do you any good. This ensures that everything gets captured in there. It's actually a really simple concept, and it's a sin that it had never been done when desktop file systems already do it, and yet these big enterprise-grade NAS systems don't. Now, the thing is that undelete data actually shows up across all the different sites. And I think we're jump forward because we're running a little slow on time. The snapshots themselves, if I come in here and say test share, I'm going to make a snapshot right now. I could set up a schedule and all of that. I'm just going to say make an immediate snapshot. Now under test share snapshots, I've got that snapshot that was just made at this time. I've got it to where I can access it through the namespace and actually see the snapshot that was made. Notice all the undelete stuff shows up in there, the files that I just deleted. Now,
it's worth mentioning that this is a file granular policy. So you can say I want to protect Office documents and I want to ignore all temp files. Because no point in protecting temp files because they're temporary by design. You don't want to waste space on any of it. You don't want to waste your performance either. So it really is a very handy policy when you can do the file granular selection.
Now I want to jump and demo one other thing. When these files got aligned to the stated intentions, the SLOs, and placed into the cloud, merely by referencing them on one site, they got laid out as per spec on the other site. I added the thing to have it placed in the cloud. I have things set up to automatically harvest image recognition metadata. So as these files were being put in the cloud, they get auto-classified, in this case using Amazon's own image recognition. And those tags that come out that says what's in those pictures actually get added into the extensible metadata within Hammerspace. And so you can look at any one of these files and see what the metadata is on it.
So you're running recognition on any picture that comes into the system here. Are you passing the recognition fees on to the customer?
So this service is actually being run in the cloud under their account, so it would get billed to them, by Amazon in this case. And if they connected it to another service, so here, image 9, it recognizes an animal, canine, or whatever. Now, because this is a metadata database, I can actually run map reductions and queries and collations, and that's this here where I've actually said, instead of looking at each file and what's in it, I want to collate things by all of the tags and tell me what files have that tag.
Right.
So it says it recognized transportation in 12 files. Here are the top 10 based on the confidence interval. It recognized vehicle in these files. So somebody do me a favor and pick one of these tags to go off of.
Animals.
Animal, okay. So this is shorthand, and I'm sorry I'm using the command line here. We do have some tools for Windows.
You won't get any flack here.
I prefer to see this. We're not on Windows here.
Okay, good. All right, so I select animals, and now
Yourself, Larry.
I was waiting for him.
so this command, what it does is it actually sets the selected attribute to a formula, and it does that on the root of the share. That formula is inherited and evaluated in the context of each individual file. So selectedness is actually found on each file. And you can see some of them, you can see the confidence interval, others are false. But better yet, I can just go into a pseudo directory, a smart directory, and it's going to list just the things that were found with it. Do it visually. I've got now all of the things. Well, I hate the file browser. My Mac is still. Let me do this. Yeah, get him to refresh. There we go. Okay. So those are the things which were recognized. Why is he doing that? With it in it. Okay.
So that's all the animals.
Sorry. Those were the things that have animals, and the Mac Finder is misbehaving on this sometimes. I don't know why. So these are the things that it recognizes with animals in them. And then the things that were not selected, this is the inverse of those things. Right?
Animals and not animals?
Animals and not animals. Or I could do...
hot dog or not hot dog?
We want to move forward.
Okay.
Quickly.
Yep. Okay. So the thing about the metadata is it's inherited. It's tags like you would have in Object Store, but it's actually much more sophisticated because you can embed formulas that derive things from other pieces of metadata. So you can build auto classifiers and so forth. They can be rendered as smart directories. And by the way, not just a directory, but those selected things, it actually is a reflection of the entire namespace through the filter, which could then be mounted so clients might be limited in what they can see based on predicates in the metadata. Okay, questions?
Do you want to show this through the Windows?
Let's jump to that, yeah.
Just quickly.
I know you guys said you're not Windows folks, but let me jump here.
No, you said you're not Windows.
Yeah.
No, Larry said it.
The only thing I know how to use point, click, point, kit.
Oh, great. How do my screen got shrunk while I wasn't here. How do I get my Windows?
Just get the
If you win arrow right, that'll fix it.
the green arrow, maybe?
Okay.
So while we are waiting for that, one quick question is, say for example, I was working for a company, I want to deploy this, I want to have a minimum set of, say, appliances, so Anvil or the DX machines, to ensure that I don't lose data at any point.
So a high availability setup.
Exactly. So how per platform, how much infrastructure you're going to need?
So you would need at least 2 distinct physical machines. You can deploy Anvil and DSX as VMs on those, but you need to have at least 2 for redundancy both in the metadata and in the DSX services layer. So it at most takes 2 pieces of physical infrastructure to have a redundant environment.
Right, and so, for example, 2 platforms as well, I presume, so that just to make sure.
Oh, the storage in the back end?
Exactly.
Well, it depends on whether you want to have resiliency beyond what one of those offers. If I say I need 3 nines and I have a NetApp, that's more than sufficient at meeting 3 nines. If I say I need 10 nines, a single NetApp's not going to do. And the system would want to put the data in multiple places to achieve that.
How do you scale? For example, as your data grows, obviously this one source of truth, naturally everyone will put everything in there. So how do you, at what point does it auto scale?
Right, so Anvil is itself a scalable service. A single share right now is served from a single Anvil or Anvil pair for HA. So if you want to get more metadata scalability, you would have the namespace separated, right? That way you have all of the locking and stuff stays very fast and localized, to within the one share. So Anvil is itself a clustered service, but it is sharded as whole namespaces. So yeah, we're not doing sub-namespace auto-sharding. That's above and beyond and not typically needed, yeah.
Yeah, real quick, back to those infrastructure questions, nuts and bolts kind of stuff. Mm-hmm. Do I need to put Anvils like in multiple availability zones?
So yes, typically, if you want redundancy, you would spin up Anvil and DSX at the multiple sites, and those becomes the caretaker of those physical resources and the renderer of the file systems that it's participating in sharing, okay. Right? And so it's managing those resources, distributing the data, serving the local clients, and then eventually becoming consistent with the other Anvils that are also participating with that share at the different sites. Okay, so quick thing here. This is from a Windows machine. I've got, and this is, I'm not sure how to get this guy. I know, it's because the screen got shrunk after I started the RDP session, and now it's not letting me scroll.
Windows for the win.
So how do I get to the broad? Anybody know how to use Microsoft RDP?
Hold down the Command key and then hit your left cursor.
Command key.
Command key left cursor, if it gives you the Windows key.
Oh.
Oh, no, that just snaps right. Okay. There you go.
Okay.
No, you still can't. Yeah.
I am.
If this is just doing the same thing in Windows that you're doing in Linux, that's fine. We have 30 minutes left, so.
No, this is a little different. It actually, through the Windows File Explorer, allows you to manipulate the metadata, including putting formulaic metadata.
Oh, cool.
So it's kind of cool because you can basically go in and on a directory say, or on the share, put a formula that says everything that's bigger than this, or that's recognized this thing in the image, or any other metadata. You can put a filter on it and create a new tag where the evaluated result of that is dependent on the specific file. And then you can use that tag to put policy and say things that have been classified as this need this data governance or so forth.
Do you have a SharePoint connector that does something similar?
Not yet. No. Yes.
I'm curious, so you're showing a lot of examples of consuming the file shares on the client side. Mm-hmm. And there's a lot of other solutions out there that also address the need for a distributed file system with metadata and a whole bunch of other stuff on the client side specifically. So, obviously I'm thinking about Dropbox, Box, OneDrive.
That is actually a really good analogy. This is like every organization being able to have their own service like Dropbox that's internally using their infrastructure.
Why would I choose to inherit the administrative overhead of managing Hammerspace as opposed to simply consuming one of these other SaaS?
For data-intensive workloads. So our main target are the guys who are either want to have their own data and don't trust putting it in the cloud. A law firm, universities, research institutions, or they need parallel access, whether that's rendering or genomics data. You're not going to suck those over a straw from somebody else's infrastructure. It needs to run next to the compute. See, the problem with Dropbox is those are disparate from the compute. You're not going to automatically run an application that consumes it.
So I've been looking for these types of solutions for the past 5 years or so, whatever. This is hard. So,
yes.
Like you mentioned the genomics use case. Like when I've tried to do this in the past, you present a universal file system, a global file system. I'm sitting in Germany. I have a data scientist sitting in New Jersey. This is a real use case, and they access. They're sharing data, and they go to perform analytics across a set of scientific data, and they see it. However, it is slow because the data is located in Seattle. The problem becomes perception is, Keith, you gave me this great new tools that I can surface the data, but it's useless because it's not local to where I'm.
In our world, that's really simple. You set a policy that says, I want a local copy of these things. And and it can be this share, this directory, things that are tagged this way.
Yeah, and other solutions do something similar. The problem being that you can never predict. When you're talking about petabytes of data, you can't predict what needs to be where, and it causes a perception problem versus a technical problem.
That's right. But generally going to a granular solution, which the others don't, and the fact that you can work at the individual file instead of working at artificial collections of volumes can help you solve the mass of data problem, because now it's only the specific files that you're talking about that need to be transferred, not the whole catalog, not a whole snapshot, etc.
So
yes, but you're quite
Corey would be very angry at us right now having the conversation of shipping data from site to site. The
other thing is that because the data is deduped and compressed, what you end up with is the catalog of the unique strings, and you're not transferring anything that's not already present based on its collision-free cryptographic hash. So it minimizes the transfer by actually being content aware and only transferring the pieces that are needed to rebuild the thing on the other site. Yep, there's only so much you can do, but we're doing what can be done. Making it granular and making it catalog and single instanced and minimize transfer.